So we have force, motion, and energy. So ano ba yung first? So first, we have Newton's law of motion. So sino ba ang nag-propose ng Newton's law of motion? So Isaac Newton compiled the three laws of motion in his Mathematical Principles of Natural Philosophy and published in 1687. So, ibig sabihin, yung Newton's law of motion, so nagmula lang kay Isaac Newton. So, we have three laws of motion. This is called law of inertia, law of acceleration, and law of interaction. Then, first, the law of inertia. So, the law of inertia states an object at rest remain at rest and an object in motion continue to move with constant velocity unless acted upon by a net force. So, ibig sabihin lang sa law of inertia, once you move, there are force and when you rest, so, no force. So, ibig sabihin, kapag gumalaw ka, meron tayong tinatawag na force or yung meron tayong lakas or puwersa na ginagamit. So, kapag wala kang ginagawa, ibig sabihin wala kang force or wala kang, hindi ka gumagalaw, wala kang force. Then, kapag gumagalaw ka, meron kang tinatawag na force. So, ibig sabihin, ano ba ang force and net force? So, force produces change in the motion of an object. So, sabi ko nga kanina, once na gumalaw ka, meron tayong tinatawag na force o meron ka ng force. Then net force is the sum of the forces acting upon. So, ibig sabihin, once you move, meron tayong tinatawag na force. So, sabi nga, kapag gumalaw ka, may force. So, all in all, kapag natapos mo yung ginalaw mo or gumalaw ka, yun ang tinatawag nating net force sa sum or yung kabuuan ng force na ginamit mo or na ginawa mo. So, that is the law of inertia. Once you rest, there is no force and once you move, there is force produces change in motion. So, that is the law of inertia. We have the law of acceleration. So, accelerations daw means change in the speed or yung pagbabago ng bilis ng isang object sa isang direction at sa or both or yung parehong bilis or speed na sa magkaparehong direction. So, the law of acceleration states an object is directly proportional to the net force applied on it and inversely proportional to its mass. So, ibig sabihin, ang isang object daw directly proportional or katulad sa net force na in-applied and kaiba naman sa mass or sa bigat ng isang object. So, ibig sabihin, sa law of acceleration, meron tayong ginagamit na formula which acceleration is equals to force over mass or force is equals to mass multiplied by acceleration. So, the unit of measure of force of Newton. So, ibig sabihin kapag force, ang unit niya is Newton. So, ang Newton equivalent to 1 kilogram meter per second squared. So, ibig sabihin, tatandaan niyo, 1 Newton is equivalent to 1 kilogram meter per second squared. So, ang unit naman ng mass natin is kilogram. So, multiplied by the unit of acceleration. So, ang acceleration natin is meter per second squared. Then, is equal to the unit force of Newton. So, yan po ang mga unit nila. Mass, kilogram, acceleration, meter per second squared. Then, force, we have Newton. So, Newton is equal to 1 kilogram meter per second squared. So, yan po. You have an example. Sa example, so, ayan, basahin niyo po yung problem. Then, ito yung given, 220 kilogram. So, 660 Newton. So, ang hinahanap natin dito is the acceleration. So, the acceleration, so, paano ang formula niyan? So, solution A is equals to F over M. So, ibig sabihin, force over mass. So, 660 Newton. Then, 220 kilogram. So, ano ang magiging sagot niyan? We have 3.0 meter per second squared. Ang hinahanap natin is acceleration. The unit is meter per second squared. So, that is the example of law of acceleration. Next, the third law of interaction. So, ibig sabihin lang sa third law of for every action, there is an opposite and equal reaction. So, ibig sabihin lang sa law of interaction, sa bawat galaw mo or sa bawat ginawa mo, merong katumbas or kaukulan na reaction sa isang object. So, ibig sabihin lang, so, some applications of the third law of motion. So, a rocket pushes out of the exhaust which thrusts upward. So, your head hurts when you bump on a wall. So, ibig sabihin lang, yung isang action na ginawa mo, merong corresponding na back sa'yo. So, yun nga, your head hurts when you bump on a wall. Try mo i-bump yung ulo mo sa wall. So, kung ano yung naramdaman mo, yun yung third law of interaction. Or yung third law of motion. So, 3. Your hand hurts after slapping a person. So, try mo, sampalin mo yung katabi mo, tapos kung ano yung magiging reaction niya. So, yan po ang third law of interaction. For every action, there is an equal and opposite reaction. The next, work. So, work is done when a force acts on an object and causes the object to move along the direction of the force. So work din, meron tayong tinatawag na um, ayan. So, ayan muna. Para daw masabing force, so kailangan meron kang applied. Yung force daw i-apply mo sa isang object. Then, yung object daw kailangan merong displacement. Then, the direction of the displacement must be a component of the force applied on the object. So, then po ang force. Ay, work. So, matatawag mo daw na work kung yung tatlo na yan is natapos. So, sa work din, meron tayong so work is equals to force times distance. So work, joule, force, or magnitude of force, and this D is equals to magnitude of displacement. So, ang unit ng work is joule, unit ng force is Newton, and distance is meter or displacement. So, here the sample problem. So, ayan. So, ang given natin is 100 Newton and 5 meters. So, hindi natin papansinin si 15 kilograms. So, ang hinahanap natin dito is work. So, ang solution natin is work is equals force times displacement. So, 100 Newton multiplied by 5 meter, we have 500 Newton per Newton meter or 500 joule. So, that is the formula of work. Work is equals to force multiplied by distance. Then next, we have power. So, power is the rate of doing work. Kung wala daw work, walang power. So, power, we have also a formula. So, power is equals to work over time. So, work divided by time. So, power, so meron din tayong unit dyan na joule per second. So, joule per second is equivalent to 1 watt. So, 1 watt. So, tapos, yung time natin is equals to unit of second. So, all problem. So, ang given natin dito is 420 point, or 42.0 kilogram, then 0.25, then 2.0. So, sa power, meron bago daw natin makuha yung power, kailangan kukuhanin muna natin yung work. So, ibig sabihin, ibang work naman ang formula dito. Instead of force multiplied by work. So, work is equals to mgb. So, kukuhanin natin 42.0, 9.8 meter per second squared, and 0.25 meter. So, pag nakuha na natin si work, eto na siya, 102.9 joule. Then, the power is, so, ang sabi ko nga kanina, pag power is equals to work over time. So, work, 102.9 divided by 2.0 is 51.5 joule per second or 51.5 watts. So, tatandaan nyo sabi ko kanina, pag sinabing inangat or nilift, meron na siyang gravity na constant, 9.8 meter per second squared, kahit hindi ko sabihin, or um, kahit hindi nakalagay sa given. Basta mayroon kayong nakitang word na lift or inangat, meron siyang 9.8 meter per second squared. Tatandaan 9.8 meter per second squared. Pag umangat na siya, 9.8 meter per second squared the gravity. Then next, we have the energy or the ability to do work. So, sa energy, meron din tayong for the potential energy, stored energy, gravitational potential energy, and elastic potential energy. So, dito, sa energy, meron din tayong tinatawag na formula. So, meron din tayong gravitational potential energy. So, sabi ko nga kanina, PE, potential energy is equals to mass, gravity, and height. So, PE potential energy, mass, or mg. Sabi ko nga sa inyo, once na sinabing may binanggit sa problem na word na lift, inangat, upward, umakyat, basta yung word na umangat siya, meron tayong gravity kahit hindi ko sabihin, kahit hindi ko ilagay yung 9.8 meters per second squared, kailangan alam nyo yan. 9.8 meter per second squared, constant. So, then, height or the position of the object from the ground. So, the gravitational potential energy is unit joule. So, joule, tatandaan nyo kapag gravitational potential energy. So, example. So, ayan, basahin nyo. Then, we have given 2.0. Then, 0.45, sabi ko nga kanina, pag sinabing inakyat or umangat siya. So, meron tayong gravity na 9.8 meter per second squared. So, constant. So, napakadali lang yan. mgh multiplication. 2.0 times 9.8 times 0.45. So, 8.8 Newton per meter or 8.8 joule. Tatandaan nyo ha, 9.8 meter per second squared once na yung bagay inangat, umangat, umakyat. So, yan po yun, 9.8 meter per second squared kahit hindi ko na ibigay sa inyo. So, yan na tatandaan pag mayroong gravity. The next, we have kinetic energy. So, napakadali lang din ang formula niyan. Ke is equals to 1 half mv squared. So, Ke, kinetic energy, mass, and speed. Then, so ayan, problem. So, we have given 200 kg and 12.0. So, 1 half mv squared, 1 half 200 kg and 12.0. So, 12.0, i-squared nyo muna siya, then multiply by 200. Then, i-half nyo, we have answer na 14,400 joule. So, yan. So, next we have sound. So, a disturbance that move through a medium in the form of mechanical energy. So, yung sound, ito yung naririnig nyo ngayon sa akin. So, yan ang tinatawag nating sound. So, the medium through which sounds travel can be solid, liquid, and gas. Next, the speed of sound. So, sound is a disturbance that carries energy, travels through a medium. So, speed refers to how fast the disturbance travels in the medium. So, meron tayong sound and meron tayong speed of sound. So, dito muna tayo so the frequency refers to the number of waves through the input. So sa sound, meron tayong, or speed of sound, meron tayong formula na speed is equals to distance over time. Speed of sound, and then we have speed of sound, wavelength, and frequency. So the wavelength is the distance of travel in one period. Next, so dito muna tayo sa speed of sound. So distance over time. So speed of sound. So 2,500 meters over 10 seconds. So 2,500 divided by 10, 200 meter per second. So tatandaan kapag speed of sound or time or tsaka distance lang, ito lang ang gagamitin nyo. So this speed, distance over time. So how about kapag length naman? So kapag meron naman tayong wavelength at frequency, ito naman ang gagamitin yung formula. So ang hinahanap natin dito is the wavelength. So sa wavelength, so given na si frequency and speed. So ano lang natin sila, 350 meter per second square meter per second and divided by 600 beats per second. So, pag multiply nyo lang, pag divide nyo lang sila, so we have 5.83 meters. So, yan po ang, kapag tatandaan, kapag distance at time, ang gagamitin yung formula is speed, or yung speed is equal to distance over time. So, kapag yun ang given. So, kapag frequency, wavelength naman, so, ito ang gagamitin yung formula. So, tatandaan nyo yung bawat formula ha. Next, we have, so, yung light, ito yung liwanag. So, we have color components of visible light. So, visible light also known as white light. So, yung white light daw composed of different components. So, first, we have the first dispersion muna. So, dispersion, the separation of colors from visible light. So, theories of light. So, meron dalawang tao na nag-propose ng kung saan daw nagmula ang light. So, si Isaac Newton, so, siya ang nag-propose ng light daw ay nagmula sa tiny particles gaya ng bullets or yung bala ng barel. So, si Isaac Newton ginamit yung corpuscular theory. Then next, we have Christian Huygens. So, siya naman yung nag-propose ng wave theory na sinasabi niya na ang light daw nag-behaves like a wave that carries energy. So, yung Sabi niya, yung light daw yung nagkikaris ng energy. So, Isaac Newton and Christian Huygens. Then, so, we have properties of light. First, the reflection. So, the properties of light. So, yan yung nakikita mo kapag tumingin ka sa salamin. So, yan ang reflection. The next, speed. So, yan daw yung bilis ng light or ng liwanag na nagka-travel sa isang medium. And then, refraction. The light bends when it passes from one medium to another. So, ibig sabihin, ito naman sa refraction, ito yung sa mirror. So, nagbe-bend siya or nakikita mo siya sa isa't isa. Or yung example is yung flashlight. So, di ba kapag tinutok mo yung flashlight sa pader, nagre-reflection din siya sa isang pader. So, yan ang tinatawag nating refraction. Then next, we have total internal reflection. So, yan yung combination of reflection and refraction. Then next, we have dispersion. So, the properties of light, which visible light is bent into different colors according to their frequency and wavelength. So, dispersion, example dito is yung sa rainbow. So, sa rainbow, di ba, hindi lang natin nakikita, pero meron siyang dispersion na tinatawag. So, yun yung pagkakahati-hati ng bawat color. So, kung ano yung pagitan ng bawat color or yung Roy G. Biv, yun yung tinatawag natin dispersion. So, next, we have diffraction, another property of light, characterized by light that passes through the small opening. So, example lang dito is sa diffraction is yung mga butas sa bubong. So, di ba kapag mayroong butas sa bubong, nagre-reflect or lumalagpas dun ang light. Then next, interference. So, as light travels another light, may cross it apart. So, ibig sabihin, yung dalawang light nagko-cross apart or nagkikita. So, yan ang um, color components of light. So, we have wavelength and frequency of light. So, wavelength. So, sabi ko nga kanina yung rainbow. So, rainbow, example niyan, perfect example ng wavelength. So, reverse to the distance over which the shape of the waves repeat. So, inversely proportional to frequency. So, the longer the wavelength, the lowest of frequency. So, example nga dun sa rainbow, so, di ba, pinakamataas na wavelength is, or pinakahabang wavelength is red. So, ibig sabihin, ang red ang pinakamababang frequency. So, then, ang pinakamababa is violet. So, yung violet, pinakamababang wavelength or pinakamaigsing wavelength, pero makitaas ang frequency. So, we have heat and temperature. So, heat and temperature, ano ba pinagkaiba nila? Temperature, so temperature, the sensation of hotness and coldness. So, dito malalaman kung mainit or malamig. Then, heat, because, so, ito naman yung nagiging dahilan kung bakit lumalamig at nagiging mainit. So, yan po ang heat and temperature. We have different, so temperature is measured in different scale using thermometer or a thermometer. So, yung temperature daw natin, nami-measured siya. So, in different scales, so mamaya sasabihin natin kung ano yung different scales na yan using a thermometer. So, or thermometer. So, si Galileo Galilei, siya ang unang inventor ng mercury thermometer. So, si Galileo Galilei. So, clinical thermometer and laboratory thermometer. So, ito, ang clinical thermometer, so, yun yung ginagamit sa mga ospital at mga clinics. Then, laboratory thermometer, so, kung nakapunta na kayo sa mga laboratory ng mga scientists, mayroong iba't ibang klase ng thermometer na ginagamit kung ano ba ang experiment na gagawin nila. So, yun yung laboratory thermometer. Then, we have two kinds of thermometers, so mercury and alcohol. Meron dalawang klase. Ayan nga yun. So, mercury thermometer is hindi naman na siya common. So, ang madalas ginagamit na ngayon is alcohol. So, bakit ba nawala ang mercury thermometer? Kasi nga, toxic siya kung gaya ng nakalagay dyan sa comparison. So, mahal din ang mercury thermometer, then toxic. So, toxic talaga ang mercury thermometer kasi once na mabasag yan, pwedeng makaharm sa tao yan. Unlike the alcohol thermometer, cheap na and non-toxic or mura at hindi rin siya toxic or harmful sa tao. So, tingnan nyo kung ano yung pinagkaiba ng dalawa na yun. So, ayan yung two kinds of thermometer. Then next, we have different scales used in measuring temperature. So, So, ayan yung different scales na ginagamit sa pag-measure ng temperature. So, first, we have Celsius scale. So, Celsius scale. So, si Anders Celsius ang nag-propose ng Celsius scale. So, from boiling point to, so, ayan. So, Fahrenheit scale. So, si Gabriel Daniel Fahrenheit naman ang nag-propose nun. Then, Kelvin scale. So, William Thomson Kelvin. Then, Rankine scale. So, ayan. So, si Gabriel Daniel Fahrenheit, siya ang unang physicist na gumamit ng first mercury thermometer. So, instead of alcohol thermometer, siya, ginamit niya is mercury thermometer. Then, ayan po ang different scales used in measuring temperature. So, itandaan yung apat na yan. We have electricity and magnetism. So, the next, we have ampere. So, ampere, unit for current. So, unit for current ampere. So, named after Andrea Marie Ampere, a French mathematician, physicist. Tatandaan kapag ampere, current. Ampere, current, Andrea Marie Ampere. So, current daw is ginagamit para ma-measure is ammeter. So, para daw ma-measure natin ang current, ginagamit natin is ammeter. The next, we have electrical power and electrical energy. So, kapag daw isang energy na convert into another form, such as mechanical energy, heat, or light, it becomes electrical power. So, then next, we have electric energy. Then, battery, the source of energy of a circuit. So, ibig sabihin, kung walang battery, walang pagkukuhanan ng energy. Then, switch determines whether or not a circuit is ready for operation. So, common naman siguro kayo sa bahay nyo, merong switch. So, the next, we have resistors. Device which controls the flows of electricity in an electric circle. So, sa resistor, tanong nyo kung ano sa mga tatay nyo ngayon. Kung ano yung pa yung resistor, switch, and battery. The next, so, ayan. So, since in series circuit, 10, 20, 60. So, R1, R2, R3. So, ano lang, napakadali lang. So, pagpa-plus-plusin nyo lang. So, in parallel, 30, 30, 30. So, ano lang yan, divide muna bago nyo pag-plus-plusin. So, ayan.